Hello student, welcome to my class. Today we are going to discuss about your second year syllabus, that is optics, and here we will discuss what is refraction of light. Actually we already discussed two lecture, first lecture and second lecture. The image formed by plane mirror or reflection, laws of reflection in plane mirror, and second one how image form in case of spherical mirror and reflection process or reflection procedure in spherical mirror. Clear? Now today we are going to discuss about what is refraction of light. That means it is the phenomenon or it is the process of the changing of path of light when light ray travels from one transparent medium to another transparent medium is known as refraction of light. So suppose there is a two transparent medium. Suppose this is the diagram and here this is one medium. You can take any glass medium or any medium. This is medium number 1, this is medium, first medium, and here this medium is air medium, and second, suppose this medium, this is medium 2 and this medium is 2, and suppose this medium glass medium, and third medium this medium, and this is medium number 1 because this is air and here air medium. Clear? Okay. When a incident ray incident on the interface, this is one interface, suppose this is x and this point y, and this point x y, and this is x dash and this point y dash, and there is a incident ray which incident at point O obliquely, and in this case here first we have to draw a normal which is separated by two medium, and this is normal, and you already know what is normal. Normal is always perpendicular to that interface. That means this angle is known as angle of incident I. Clear? Okay. If there is no medium, suppose there is air medium, you already know light, the path of light is straight line for a given medium, for a homogeneous medium. But here there is two medium, medium 1 and a medium 2. So light changes its direction. If there is no medium, then light traveling, it can travel this direction if there is no another medium. Clear? But there is first medium and second medium. So in this case, when light travel from first medium to second medium or rarer medium to this medium is known as rarer air medium, and this medium is known as denser medium. So this is incident light, that is this is incidence ray, and when light traveling from one medium to another medium, it changes its path. That means it changes or it bend this path. Clear? And the angle, and this ray is known as refracted ray. Refracted ray. So this angle is known as angle of refraction. So here I is angle of incidence, and what is R? Angle of refraction. So angle of refraction is the angle between normal and refracted ray. But here you already know when light traveling from one medium it is straight line, but this is one medium. So when light traveling in air medium, the path of the light which is straight line, and when it just enter to the second medium, then light bend towards normal. That means this light deviate, and this angle is known as delta, and delta is known as angle of deviation. Angle of deviation. Clear? So this angle is known as angle of reflection. And next thing, now this ray this point O and this point suppose B, and the ray OB which is traveling in straight line direction within the medium, and when this ray or refracted ray reach at this point or reach at this interface x dash and y dash, then again it changes its direction or again it changes its path. Now we have to draw a normal here, and this is normal n1, suppose this normal n2. But in this case, if there is, suppose there is no any medium and only one medium, this medium is continuous medium, then in this case the path of the light like this, that means this is the line of action of, this is line of action, or this is line of action of incidence ray, and this is line of action of refracted ray. But in this case, when light traveling from denser medium to rarer medium, then in this case the light changes its direction and the light bends away from the normal. This is normal and the light bends away from the normal, like this direction, and this ray is known as emergent ray, and this angle, suppose this angle is known as E, and what is E? E is known as angle of emergent or emergent angle. Clear? So this is refraction of light. That means when a light traveling from air medium to denser medium, the light changes its direction, and in this case when air medium to denser medium, the light bend towards normal. The light bend towards normal from its original path, and deviation angle, that is delta. Clear? Or you can write the value of delta which is equal to this angle and this angle equal. So you can write that is I equal to r plus delta and delta equal to I minus r. This is angle of deviation, that means it deviates from its original path. But in this case this is one medium, so in this medium the light travel again straight line path, and when this light reach at point B, then it faces an interface which is separated by two medium. This is denser medium or glass medium, this is air medium. So here if you draw a normal this line, but light when travel from glass medium to air medium, it bend away from the normal. It bends because this is initial line of the refracted ray, or this line is known as line of action of refracted ray. Now the refracted ray changes its direction while coming from glass to rarer medium, and it bends away from the normal and emerges out this direction, emerges out BC direction. Clear? This is known as emergent ray, emergent angle. This is angle of refraction. But here these two lines are parallel, and these two lines, because here angle is 90 degree and here also angle is 90. These two lines are parallel. Since xy and x dash y dash, so you can write this angle which is equal to this angle. So here what is r? For this interface, I is angle of incident. For second interface, here r is angle of incident. Because at that time for second refracting surface, for second interface, this ray which is incident ray and this ray is known as refracted ray. Clear? Okay, this is known as refraction case. Next case, suppose there is another medium here, and in this case when light incident on the surface normally, if you draw a normal at that point, then this normal also pass through this angle of incidence or this incident line. But here the angle of incident is 0. You already know, according to law of reflection, the angle of incident equal to angle of reflection. So in this case the light transmit, if these two medium are transparent medium, then light travel undeviatedly like this. This is incident ray, and this ray is known as refracted ray. And here angle of incidence and angle of refraction is 0. Here I equal to 0 and R equal to 0. Again it face another interface and it incident perpendicularly, and here angle also 90 degree. If you draw a normal, then the normal which is lies on the reflected ray. So here again the ray travels in this direction, and this is known as emergent ray, this is incident ray, this is emergent ray. Clear? These are the process of refraction. Now let's start. Now let's start what is laws of refraction of light. So there is two law. First law, here suppose if we observe this interface xy, then here this interface xy, and here air medium, and this medium, that is glass medium, and this interface xy, here this is angle of incident I, and this is normal n, and this is incident angle of incident, and here this is line of action of incident, but here the ray bend towards the normal while it is coming from air medium to glass medium, and this angle is known as angle of refraction, and this ray is known as refracted ray. That is refracted ray, and this ray, it is incidence ray, and this point is known as point of incidence. So according to first law of reflection, the incidence ray, normal incidence ray, normal and refracted ray to the interface at the point of incident, at the point of incidence, all lie in same plane, and that plane is perpendicular to the interface. This is first law of refraction. That means the incident ray, normal and refracted ray to the interface, this is x and here y, to the interface which lies in same plane. This is one plane, and here this plane consists incident, normal and reflected, and that plane which is perpendicular to this interface, because this is interface and this is incident, here normal, and this point refracted ray. That means all the rays are lies one plane, and that plane which is perpendicular to this interface, and this is known as first law of refraction of light. And according to second law, that is, this is first law and second law. So you already know what is second law. The sign of angle between the sign of angle of incidence, the sign of angle of incident, or it is the ratio of, you can write, it is the ratio of it is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for pair of medium. That means if there is two medium, this is medium number 1 and this is medium, this is 2 and first medium, and the medium which is separated by a interface, and in this case we can apply this second law, and here the angle of this is incident I and here the angle of refraction R, and according to this law, that is sine I divided by, it is sine R, sine of angle of incidence divided by sine of angle of refraction, which is a constant quantity, and that constant quantity can be write, that is sine I divided by sine R, which is equal to a constant is known as refractive index of second medium with respect to first medium, and this is a constant quantity. Clear? So what is mu2 and mu1? And here mu21 is known as relative refractive index of second medium with respect to first medium, and it is a constant quantity for two medium. Clear? So we have, that is sine I by sine R, which is equal to mu21, and this is constant quantity. And what is mu21? That is known as refractive index, or this is relative refractive index, relative refractive index of second medium with respect to first medium, and this is constant quantity. So this constant quantity or refractive index, we simply write a refractive index which is independent of angle of incidence, independent of, that is angle of incidence, and that is angle of refraction. Why? Because if angle of incidence increase or decrease, respectively angle of refraction increase or decrease, at that time which is constant quantity. So refractive index depends on refractive index depends on the following factor, or the factor on which refractive index of two medium depends. So first point, it depends nature of the medium or nature of two medium. Second point, it depends on, that is color of wavelength of light, color of wavelength of light travel. Next point, third point, it depends on temperature of the medium. Clear? Okay, these are the following factor on which refractive index of two medium depends. So now let's start. What is relative refractive index and what is absolute refractive index? So now let's start. Here relative refractive index or absolute, first we will discuss absolute refractive index. Absolute refractive index. So what is absolute refractive index? That is absolute refractive index is symbolized, that is mu, and this absolute refractive index is defined as, that means it is defined as the ratio of speed of light in vacuum to the speed of light in other medium, is known as refractive index or known as absolute refractive index, and that is mu equal to ratio of speed of light in vacuum, that is C divided by V. This is known as absolute refractive index, and this absolute refractive index is a constant quantity, because here this is C and V, and C is speed of light in vacuum, and what is V? V is speed of light in any other medium other than vacuum or other than air medium. So in this case, what is mu? Mu is a dimensionless and unitless physical quantity. It is a dimensionless and unitless physical quantity, and this physical quantity only depends on the following factor. Clear? So it is a dimensionless and unitless physical quantity. Suppose there is two medium, or suppose when light traveling in air medium, at that time the absolute refractive index will be, we can write here, that is mu equal to C by, and second medium also, if there is two medium, air medium and air medium, light traveling in one medium which is a constant quantity, and for one medium its path is a straight line path. So at that time mu equal to C by C, and C equal to constant quantity, and its value is 1 for vacuum. Then the mu for vacuum, the absolute refractive index of light in vacuum, which is equal to 1. But for other medium, that means the medium other than vacuum, in this case that is mu equal to C by V, or in vacuum the speed of light which is equal to 10 to the power 8 meter per second, but other medium it is less than, and this quantity is less. So the value of mu, the value of absolute refractive index is always greater than 1 for other medium, or you can write this value is greater than equal to 1. Why? That means this value is equal to 1 for vacuum, and for other medium or other than air medium, its value always greater than 1. Clear? This is all about absolute refractive index. So this absolute refractive index is maximum, so it is maximum for vacuum, or the absolute refractive index is maximum in vacuum, minimum in vacuum, because this is 1 here, minimum is vacuum, and for other medium it is greater than 1. Or you already know the velocity equal to distance by time, or we can write the velocity of a particle in other medium. Suppose this is air medium and it is another medium, suppose glass medium, but in this case this is one interface here, and here the light traveling this medium, this is air medium or a vacuum. Suppose here speed of light V, speed of light C, and because the light consists 3 important factors. What are they? So first important factor, that is velocity, second important factor, that is wavelength, and third important factor, that is frequency. You know what is V and lambda? V and lambda which depends on the medium. But what is f? F means it is the frequency of the source. If we want to change the source, then frequency of the light also change. But while light traveling from one medium to another medium, air medium to glass medium, or a glass medium to water medium, at that time or every instant of time there is no change in frequency, but wavelength and velocity changes. Why? Because it depends on medium, but frequency does not depends on medium. This is one normal and angle of incident, and this is the line of action of incident ray, and it deviates from its initial path. It is known as r. But here the velocity, which is v2, and frequency, that is lambda 2, and wavelength lambda 2, frequency f. This is v1, this is lambda 1, and here frequency f. But here frequency remain constant while light traveling from one medium to another medium. At that time the velocity and wavelength are changes. So this medium we can write the velocity v. Suppose when light coming from air, vacuum or air medium to other than air medium, means glass medium, at that time velocity can be write, that is v equal to distance by time, and here distance equal to wavelength by time, and velocity equal to wavelength into 1 by time period, which is equal to frequency. So here that is v equal to lambda f, and here velocity of a medium increase, then wavelength of a medium also increase, while frequency of the medium is constant, and that frequency which always depends on source of light. So we can write here this relation, that is v equal to lambda into frequency. This is one medium, and here that means this v is directly proportional to lambda, because frequency is constant. Here that is f is constant, and it depends on source of light, but v and lambda depends on medium. So in this case we can write, that is v directly proportional to lambda, and if this is v1, then this is also lambda 1, because it is directly proportional. If you use this relation here, that is mu equal to c by v, or we can write that is mu equal to c by lambda, because in place of v we can replace in terms of lambda. But here c is constant quantity. For a vacuum its value never changes, but here the refractive index, that is mu, which is inversely proportional to lambda. If wavelength of the light decrease, then wavelength of the light increase, then absolute refractive index of that medium decrease. Clear? This is all about absolute refractive index. Next we will start relative refractive index. So what is the relative refractive index? It is a constant quantity, and sine of angle of incident divided by sine of angle of refraction, which is a constant. And this the second law of refraction is known as Snell's law. I forgot to write, that is known as second law. Second law of refraction is also known as this Snell's law. And what is Snell's law? We have, that is sine I by sine r, which is equal to mu to 1. That means refractive index of second medium with respect to first medium, and this is a constant quantity, and this law first given by Snell. So according to his name, this law is known as, it is Snell's law. Snell's law of refraction of light. So here we will discuss about what is the relative refractive index, and this is known as relative refractive index. So relative refractive index of second medium, suppose there is two medium, and here the medium, this is medium number 1, and here this is medium number 2. When, and it is defined as the refractive index of second medium with respect to first medium, and in this case it is the ratio of speed of light in first medium. Suppose here the speed of light in first medium, this is medium 1, that is v1, and here this is normal, and this is angle of refraction r, and this is the velocity in second medium, that is v2. And the relative refractive index of second medium with respect to first medium is defined as the velocity or speed of light in first medium to the speed of light in second medium. That means here we can write the refractive index of medium 2 with respect to medium 1, and which is equal to velocity or speed of light in first medium, that is v1, divided by speed of light in second medium, that is v2. And this quantity we can write, because this is v1 and v2, or if we rearrange this term we can write that is 1 by v2 divided by this is v1, so 1 by v1. This term can be write this format. So if you replace this 1 in terms of c by v2, c means speed of light divided by velocity in second medium, and here c by v1, because c cancel. And what is c by v2? What we already know, that is mu equal to c by v. Absolute refractive index of the medium whose velocity in that medium is v. Similarly, you can write here that is mu2 divided by mu1. So we get another relation, that is mu21 which is equal to mu2 divided by mu1 which is equal to v1 by v2 which is equal to, that is sin I by sin r, and that is sin I by this sin r. This is one important formula. And here we already know v equal to lambda into f, and this is v1 equal to lambda 1 into f. Suppose the light, incident light, which velocity v1 and wavelength lambda 1, frequency f, and here it is lambda 2 and frequency f. Frequency never changes when light from one form to another form. We already discussed. So v1 we can write that is lambda 1. So this term we can write that is mu21 which is equal to absolute refractive index of second medium with respect to first, that is v1, and v1 can write that is lambda 1 and lambda 2. So we can write that is v1 by v2 which is equal to lambda 1 by lambda 2 which is equal to here, because here f and f v1 equal to lambda 1 f cancel. So we can eliminate this frequency here. Next, that is sin I by that is sin r. Clear? This is relation. So what is mu2? Mu2 means this is absolute refractive index of second medium, and it is mu1 equal to absolute refractive index in, it is first medium. Clear? Okay. So if we discuss some important term regarding this concept, suppose there is two medium, same thing, this is incident, this is normal, this is line of action of incident, this angle 90 degree, and this angle r, this is refracted ray. This is medium number 1, and here medium number, this is medium number 2. Clear? And here velocity, that is v1, and wavelength lambda 1, and frequency f, that is v2 lambda 2 and f. Suppose first point, if v1 greater than v2, the velocity of light which traveling in first medium or incident light with velocity v1 which is greater than velocity v2. If here v1 greater than v2, we have to use this relation here, then we can write this relation, that is v1 greater than v2, or which is equal to v1 by v2 which is greater than 1, and this is v1 and v2 can be write that is mu21 which is greater than 1, and this is relation, that is sin I by sin r. So you can write here the relation, that is sin I by sin r which is greater than 1, and can be write this sin I greater than sin r, both sides sin cancel, and I greater than 1. And this relation indicate that the angle of incidence is greater than angle of refraction, while incident velocity, the velocity of incident is greater than velocity of refraction. So when light bends towards normal while coming from one medium to another medium, this medium is known as heavy medium as compared to fast medium, and that medium is known as optically denser medium. It is known as denser medium, and this medium is known as rarer medium. Clear? This is rarer medium, and this medium is known as denser medium. So in this case, when velocity v1 is greater than v2, then this second medium here, the second medium is called optically denser medium or heavy medium, and fast medium is called that is rarer medium. And this relation you can write also, that is mu 2 1 greater than 1, and what is mu 2 1, and here that is mu 2 1 equal to write mu 2 by mu 1, and which is equal to mu 2 divided by 1 greater than 1, and here mu 2 greater than mu 1. So what is mu 2 greater than mu 1? And here this is refractive index mu 1, and here refractive index mu 2. That means absolute refractive index in second medium with respect to first medium. Clear? So large refractive index, large absolute refractive index, which is denser medium, and small absolute refractive index is known as rarer medium. Clear? Okay, these are the important point regarding absolute refractive index and relative refractive index of first medium with respect to second medium. And another important thing, when light traveling from one medium to another medium, it energy losses while they deviate from their original path. And you have to remember some refractive index of different medium. For vacuum, that means refractive index for vacuum, which is equal to 1.000, and this is constant quantity, dimensionless and unitless physical quantity. Next, refractive index for air medium, which is 1.003. Clear? 1.003. Next, refractive index for that is glass medium, and this glass medium which is equal to 1.5, and refractive index for water medium which is equal to, that is 4/3, or this is 1.33 for water medium, and refractive index for diamond which is 2.43. You have to remember this absolute refractive index for the given medium: vacuum, air medium, glass medium, and water medium, and for diamond. Clear? These are the concept regarding absolute refractive index and relative refractive index. When relative refractive index increase, that refractive index is known as denser medium. When refractive index decrease, that medium is known as rarer medium. Clear? And where velocity of here velocity of light in velocity changes when light coming from one medium to another medium. Velocity wavelength changes, but frequency never changes. And velocity and wavelength are depends on the medium, but frequency is only one physical quantity which always depends on source. So it's independent of medium. If you take one example regarding Snell's law, so Snell's law, that is sin I by sin r, which is equal to mu 2 1, and you always remember this term, that is mu 2 divided by mu 1, or if you cross multiply this relation, that is mu 1 sin I, which is equal to mu 2 sin r. Clear? This is for incident and this is for refracted ray. Clear? Okay. Suppose there is a interface or there is two medium, that is medium 1 and this is medium number 2, and here the light incident, this is normal, and here the angle of incident is 60 degree, and this medium is suppose air medium, and this medium is other than air medium, and here the refractive index of the second medium, which is equal to root 3. Now question here, find the angle of refraction and angle of deviation. Angle of deviation. So how can you calculate this relation? We already have this relation, that is mu 1, that is sin I divided, equal to, that is mu 2 sin r. First we have to find this r, because this is the actual line or line of action of incident ray, but light deviate from its original path, because this medium is air medium and this medium other than air medium. So this medium is heavy medium. When light coming from rarer medium to denser medium, the ray changes its path and it's bent towards normal. This is refracted ray, and this angle is known as angle of reflection, and this angle is known as deviation. And here the deviation, angle of deviation, which is equal to r plus delta equal to I, this is angle of incident. So we can write it is I minus r, that is angle of deviation. So first we have to calculate what is the value of r. So here that is mu 1, refractive index for air medium, which is nearly equal to 1, because refractive index, that is mu 1, which is equal to 1.003, and which is nearly equal to 1. Then you can write that is 1 into sin I, and sin, that is 60 degree, and which is equal to mu to second medium, that is root 3 into sin r, and here we can write that is sin 60, that is root 3 by 2, which is equal to root 3 into this sin r. Root 3 cancel, and here we can write sin r equal to 1 by 2. So sin r equal to 1 by 2, which is equal to sin 30 degree. So sin cancel, the value of r, which is equal to 30 degree. So we get the angle of refraction. Now we have to find angle of deviation. That means the incident ray, how much deviates from its initial path, and here this angle is 60 degree minus 30 degree. So here angle of deviation is, that is 30 degree. Clear? Suppose if we take another second example, suppose there is a sphere, or this medium is suppose a glass medium or any other medium whose refractive index, which is, that is mu equal to here root 3. Clear? And here the radius of this medium, that is suppose this radius, which is equal to r, and this is the diameter. Clear? Okay, this is center of this medium, like this. Clear? Okay, now let suppose here a light incident, this medium is air medium, and here this medium also air medium, and suppose this angle of incident is 60 degree. Clear? Question, that is find total deviation. Find total deviation after to refraction. Find total deviation after to refraction. So in this case we have to use the concept, there is two interface. This is first interface, and here interface way, and this interface, suppose there is another interface B. So for first interface, this solution part, for first interface at point A, and this is the line of action of incident ray, but at that point first we have to draw a tangent this point. We already discussed in spherical mirror, and this tangent and this is normal, and you already know if we draw a normal at any point on the sphere, then this normal which pass through the center of the sphere. So this is normal at point A, and angle of incidence is 60 degree, but when light traveling from air medium to other medium, it bend towards normal. So it bend towards normal and travel this direction, and this is known as refracted ray, and this angle is known as R. First we have to find this angle R, and we have to use this relation according to Snell's law, sin mu1 sin I, which is equal to mu2 sin R, and here this is air medium and refractive index for air medium which is equal to 1. So you have to use here 1 into, that is sin angle of incident here, that is 60 degree, which is equal to mu2, and mu2 is here refractive index, this second medium, this first medium, second medium, again first medium. So we can write here root 3 into, that is sin R, and we already discussed it, root 3 by 2 sin 60, which is equal to root 3 into sin R, root 3 cancel. So the value of R which is equal to 30 degree. So this angle which is equal to 30 degree. Again, there is another interface when light traveling from denser medium. This is denser and this is rarer medium. When light traveling from again denser to rarer medium, it face a interface here. This face interface here B. And this face we have to draw a tangent, this point, this is tangent. If you draw a normal, because if there is no medium and this denser medium is continuous medium, then this is the line of action of this refracted ray. And for the point B and for this interface, the refracted ray behave as an incident ray. Now this point we have to draw a normal, and you already know if we draw normal each and every point on the sphere, then this normal which pass through the center of the sphere like this. This is first normal N1, this is second normal N2, and this side and this side equal because this is radius and this is radius and this is radius. So these are if these two sides are equal, then their opposite sides are equal. So this angle is 30 degree. Clear? If this angle is 30 degree, then this total angle also how much? This total angle also 30 degree. This angle also 30 degree. But here we have to find angle of deviation. And first case, this is angle of deviation, and suppose here angle of deviation, that is delta 1, and this total angle which is equal to 60. So this angle 30 means delta 1 here 30 degree. So angle of deviation which is equal to 30 degree. Now this case, when light traveling from denser to rarer medium, it bends away from the normal. It bends away from the level. That means this ray is known as emergent ray. Clear? And this is deviation, angle of deviation. Why? Because this is actual ray of incident ray. For this interface, then it changes its direction and it bends away. Because this is normal, it bends away from the normal, that is which is equal to delta 2. Now we have to find the value of delta 2. So we already know how can we find this value, because if we draw a parallel line here, because or if this angle 90, then this angle also, this angle and this angle is known as that is total angle, this total angle is known as, that is refracted angle. So first we have to find this refracted angle. If we use at point B according to Snell's law, this point B, then it is mu1 sin I, which is equal to mu2 sin R. And what is mu1? This is first medium, this is second medium, and second medium air medium. So for first medium, that is root 3, and sine angle of incident, this angle is angle of incident, and this is 30 degree, which is equal to mu2, this is air medium, 1 into which is equal to sine R, and here root 3 into, and sine 30 equal to 1 by 2 can be right, that is sine R, and root 3 by 2, that is root 3 by 2, which is equal to sine R, and R equal to 60 degree. Clear? This angle R equal to 60 degree. Now we get this angle of refraction, which is equal to 60 degree. But this angle of refraction is 60 degree, but we have to find this deviation angle. Clear? So what is this deviation? What is this deviation? Because this angle 30 means this angle also 30 degree, because this two line and this angle which is equal to 30 degree, and this angle is also 30 degree. And here the angle of deviation, this direction and this direction is known as clockwise direction, and here also this angle of deviation which is clockwise direction, and this angle is also clockwise direction. And here the deviation delta 2, which is equal to, that is 30 degree. Clear? Total angle 60, and here deviation that is 30 degree, and here deviation also 30 degree. So total deviation which is equal to delta 1 plus delta 2. Why delta 1 delta 2? Because these two deviations are clockwise and same direction. If one here delta 1, here delta 2 in this direction, then they are opposite, and delta 1 we can write delta 1 then minus delta 2. But here they are same direction, so delta 1 plus delta 2, and which is equal to, that is 30 degree plus 30 degree, which is equal to 60 degree. So total angle of deviation after two refraction, which is equal to 60 degree. So by using the concept of Snell's law, you can solve different type of problem regarding this concept. Now let's start. What is principle of reversibility? That means according to this principle, or you can write according to this principle, if path of ray of light, reverse after suffering different refraction and reflection, that means, or that is, it retraces its initial path or retrace its original path, and this is known as principle of reversibility. Suppose there is a interface, and this interface x and y, and this is medium number 1 and this is medium number 2. Clear? When light traveling from one medium to another medium, and here the incident, when a incident light incident obliquely on the interface x and y, now we have to draw a normal here. This is normal, and this angle is known as angle of incident I. And this, suppose here there is a source, this point O and this point A. Clear? And this is the line of action of incident ray. This is line of action of incident ray. If this second medium is denser as compared to first medium, then the light when traveling from rarer medium to denser medium, it bend towards normal. It bend towards normal. That means this direction. And you already know, when light traveling from one given medium, the path of the light which is straight line. So it just change its direction from its interface, and again it travel in a straight line direction. But we have to place a plane mirror here, or we have to place a plane mirror in such a way that then this refracted ray, this is angle of refraction r, then this is refracted ray, and the refracted ray which is incident for this plane mirror, and we have to place this plane mirror in such a way that this refracted ray which fall on the plane mirror perpendicularly. If this angle is 90 degree and this mirror is a plane mirror, now if you draw a normal this incident point, then normal is lie on the same line, and here the angle of incident which is 0 degree. Clear? Okay. According to law of reflection, if angle of incident which is equal to angle of reflection, so here angle of incident which is 0 degree, that means angle of reflection also 0 degree. Now this light retrace its original path this direction and again reach this point, and there is a interface, but here light traveling from denser to rarer medium, and when light traveling from denser to rarer medium, actually this is original path. If you choose this ray is now incident, then this is the line of action for this incident ray, and A, suppose this point is B. And when light traveling from denser to rarer medium, it bends away from the normal, and then the ray travel like this. That means it retraces its original path after suffering different type of here refraction, and this point is reflection, and this principle is known as principle of reversibility. So in this case we can write two relation. What are they? When light first medium, when light travels from or traveling from medium 1 to medium 2, suppose this medium is rarer medium and this medium is suppose denser medium, then in this case we can use Snell's law, that is sin I, and this point, this is fast when light coming from medium 1 to medium 2, and this is angle of incident, and this is sin I divided by sin r, because this angle is r and this point is normal, which is equal to refractive index of second medium with respect to first medium, or here we can write that is mu to 1, because relative refractive index of second medium with respect to first medium. This is equation number 1. Similarly, when light traveling from this direction after reflection the mirror, then when light traveling from medium 2 to medium 1 after suffering reflection on, that is plane mirror. Now this case, this is the incident ray, reflected ray, and here because this is reflection after incident on this plane mirror, now this ray is incident ray. Now this ray is incident ray. Clear? And this is interface, and here incident angle is now r. So here we can write Snell's law. By using Snell's law we can write this sin I, and here I means first medium, and here first medium is angle r. So sin I divided by sin of angle of refraction. Now this is initial path, but when light traveling from denser to rarer medium, it away from normal and this direction. Now this angle is known as angle of refraction. So this angle I, which is equal to refractive index of second medium with respect to first, but second medium refractive index can be write refractive index of second medium, this medium 1. So refractive index of second medium with respect to first medium. This is equation number 2. Now multiplying these two equations, if we multiply these two equations, we get that is sin I divided by sin r, first relation, into here that is sin r divided by sin I, which is equal to 1 sorry, that is mu 2 1 into mu 1 2, and here sin r I cancel, this is 1 which is equal to mu 2 1 into mu 1 2. This is the relation, and this relation is known as principle of reversibility, or this relation can be write, if we want to write, that is mu 2 1 which is equal to 1 by mu 1 2. So this relation indicates that the relative refractive index of second medium with respect to first medium is the reciprocal of refractive index of first medium with respect to second medium. Clear? This is the law of principle, or this is the principle of reversibility. Principle of reversibility means the light retraces its original path after suffering different type of refraction and reflection.